So today is a real special treat. We've got the former executive director of CFHCA, and it's really timely because all of this talk about hydrogen hubs and the funding from the administration and the $8 billion going into hydrogen hubs, and I believe they finally have announced some of the I guess winners. I don't know if that's the right word to use, but yeah, so welcome. Good morning, good afternoon, good evening, everybody from wherever you're dialing in from. Go ahead and put in the chat where are you at? Where are you joining us from? I'm in Dallas right now. Finally, I've been traveling for about 6 weeks, so it feels good to be back home. Yeah, put in the chat, where are you calling in from, or dialing in, or joining? I guess we're not really calling. North Carolina, cool. Hi, Joe, good to see you. Charleston, South Carolina. San Jose, Southern California, Brazil. Nice. Ogden, Utah. Colorado Springs, Colorado. Mike Kramer, Huntington Beach, Overland Park. Hi, Rick. Hi, Mike. Good to see all the familiar names and faces. Hi, Mike Kramer and Mike Hirschberg. Cool. Awesome. So we'll just do a couple of announcements, and then we've got Arlington, Virginia. Love it. So quickly, we started a podcast, and we had our first guest on our podcast last month, which was Dr. Martine Rothblatt. If you haven't watched that, you're definitely going to want to check that out. I'll stick the link in the chat. We talk about hydrogen aviation, but we also talk about digital immortality. So one of the things I like to ask people at networking events is, what do you think about death? And people think I'm so weird, but I'm like, let's just cut into the deep conversations. And so that's the kind of stuff we talked about on there, and hydrogen aviation. So you're definitely going to want to check that out. If you don't know who Dr. Martine Rothblatt is, I encourage you to read this. I'll put this link in the chat. She basically is the founder of SiriusXM, and she's making 3D printed organs. She's invested in many aviation companies. Here's her talking about hydrogen aviation and Beta. She's investing in Beta, EHONG. So this is just kind of like an expose that we did on her. Jill Biden at Beta. She's invested in Tier 1. This is the world's longest piloted hydrogen, or electric, not hydrogen. This was a battery powered flight. Yeah, and technological immortality. She's made a robot of her partner Bina. So yeah, all of this stuff is real. And so I'll put the link to this if you want to read about her, and you're definitely going to want to check out that podcast. Pretty mind-blowing stuff. So and then Shane Morris is our next guest. So if you joined us last week in Grand Forks, North Dakota, you had the pleasure of meeting Shane Morris. He is quite a character. I actually met him on TikTok. He's got, I think, over 2 million followers. I know at least over 1 million. And I know that doesn't matter to a lot of you, but that's really hard to do. And he's one of the smartest people that I know. It's funny because a lot of people at the convention last week at Flying High thought that he was like the expert in hydrogen aviation, but he's actually an expert in AI. And I asked him to come talk about hydrogen aviation. Shane's TikTok handle. Yeah, thanks, Mike. Let's just pull it up.
Well, I guess I could have Googled it, right?
Oh, it's okay. I'll stick it in the chat.
And I'll just say,
he has 230 followers, 5.8 million likes.
And I'll just say, similar to Martine Rothblatt, he is like a superhuman. I mean, just like unbelievable character. You said character. I shouldn't say character, but unbelievable person.
Yep, he is. And And that's what I like to do on the podcast is find people that are interested in hydrogen aviation, but they're also really, really, really interesting and like not the kind of people you meet every day, and then talk to them about them, who they are, what motivates them, and all of this sort of thing. He's got a grill, he's covered in tattoos. He used to work at a major record label and has managed many artists that we listen to. But he also happens to be one of the most brilliant engineers that I've ever met. He works with the Department of Defense, and he's just not somebody that you think of when you think of Department of Defense and our national security. But Shane Morris, he'll be the next guest on High Sky Monthly, so that'll be exciting. And speaking of flying high, it was a massive success. And Mike, since you're here, thank you so much in Vertical Flight Society for all of your help and support. We just had such a good time. I sang karaoke, Shang sang karaoke. And yeah, just huge thanks to all of our sponsors and all of the speakers. It was a really good time. Here are some of the pictures. This is Pradeep. This is Naveed. This is Bill Spillane, Alakai, NASA, and I'm going to forget how to say his company's name. Rishav, if you're there, please say it for me, because Aero Stratalus. I think I butchered it.
Aerostrovalis.
Strovalis. Thank you. There's Shane, there's Joe, there's Manny. They were some of our volunteers. There's Mike and Ryan. He's a really cool guy he's with Department of Defense, but he also runs a testing site in North Dakota. There's the governor, and I knew I'd forget. I mean, not governor, Senator Hoeven. I hope I'm saying his name right. So that was cool. There's Naveed and Rick. There's Shane presenting. There's Yosef, H2 Fly CEO, presenting some things that haven't ever been presented before. There's Martin with stratospheric platforms. By the way, they're professional pictures as well. These are just pictures that Mike and I took off of our phone. So there are better pictures, but these were just the ones I had available. There's Julia with Choctaw Nation, where the buffalo roam. Home on the range where the deer and the buffalo roam, or something like that. I'm messing that all up. John Piasecki Aircraft. Fiona McKay of Zero Avia. It was great meeting her in person for the first time. This is us at our networking event. There's Norbert from Leibold, Matt Moran of Moran Innovations, Jim Velasco of Aero Gear, and Pradeep again of Aero Strovalas. I think I said it right that time. This was so cool. We were basically surrounded by Predator drones during this networking event. So it was just a great time. More pictures and videos coming soon. And so Thursday, we did an invite-only meeting. We'll circulate the minutes for that meeting later today. So keep an eye out for that. And big news, big news, 7 of the hydrogen hubs were finally announced on October 13th, of course, the day that I was traveling. So there's a briefing on it today from Department of Energy, and you can register for free here. It's at basically an hour after we end here. So there's the link if you want to go register for that briefing. I think that'll be very informative. Next month's High Sky Monthly is Gael. I hope I'm saying his name, Labrie of WSP. And Mike, I think you know him. If I'm saying his name wrong, please correct me. Cool. And then if you want to register for that, let me put the link for that. And this will be a really cool one as well. Let's see. And I know I'm bombarding you all with links in the chat, but lots of informative stuff. And then, of course, we have our members area that we just launched on our website. It's sort of like our own little social media. You just go to members, and if you're logged in, which I'm logged in, you can kind of post, you can send instant messages to each other. So it's kind of like our own little LinkedIn. We're pretty new. Oh, this is Mark Van Wyk too. He's the one that presented virtually from South Africa. But anyway, so yeah, please join us. It is a private group. It's by invitation only, but you can click here and request to join, which we have 2 requests. So I will just reactor engineer. I'll do this later. Anyway, we just make sure that you're real before we let you join, because we had some fake accounts anyway. So please join us in there. It's 100% free. You all can chat with each other, ask questions, all that good stuff. And this is just me showing you how to join. Yeah, and then with that, I would love to bring up to the stage Dr. Rishabh Shrestha. He's our head of operations at High Sky Society, and literally the magic behind High Sky. Those of you that were at Flying High, you saw that I basically cannot do anything without Rishabh. So without further ado, Rishabh, take it away.
Thanks so much, Danielle. I'm flattered, I guess. I didn't know, we never expected Flying High to finish and High Sky Monthly to begin, within a week. But that's actually good, because we now get to hear from Mark Kirby. He is our distinguished speaker for today, former executive director of the Canadian Hydrogen and Fuel Cell Association. And Mark has had a distinguished over 30 years of experience in hydrogen and hydrogen technology, production, handling, distribution, and use in the private sector, with global industrial gas major Linde, fuel cell pioneer Ballard Power, separation technology company Questair Technologies, and industrial biotech company S2G Biochemicals, and last but not least, hydrogen infrastructure company HTEC. He also served as president and CEO of the Canadian Hydrogen and Fuel Cell Association from August 2019 to April 2022. Mark's passion is commercializing technology, especially clean technology, and he has done that throughout his career, whether as a young engineer pioneering clean bleaching technology at pulp mills, which he will talk about, I guess, in his presentation, or as a co-founder CEO of a second-generation biochemicals company. His priority is to see Canadian hydrogen and fuel cell companies prosper by helping them get their world-leading products into the commercial use around the world. So, Mark, welcome to High Sky Monthly. Take over.
Thanks, Trav. Really appreciate that, and also thanks, Danielle. I've really watched with admiration the work you guys have done over the past couple of years in building up awareness and enthusiasm for hydrogen use in aviation. So delighted to be here to talk with you. And just could you confirm that I am indeed showing here on the screen, and you can all hear me?
I don't see you, but I don't know if it's just my view. Do you guys see him? Put a 1 in the chat if you see him.
All right. So, yeah, I can't see myself, so it's a bit of a strange thing here, but
okay, we don't see you.
0. Earlier, and all of a sudden it stops. Oh, start it again. Let's see if that works.
Okay, no worries.
Okay, well, let me try sharing my screen here, and let's see if that actually gets us on the screen.
Yeah, we totally tested before we let people in, and it's always fun when it does funny things live. Yeah, you're just black. We see your screen, but your camera is just not working.
No, my camera's not working. Well, that's okay. You don't get to see my my lovely grizzled face. But again, really appreciate the opportunity to be here and to talk a little bit about hydrogen supply and maybe how it might relate to aviation. First off, got to start by thanking CFHCA sponsoring members, Canadian Nuclear Labs, National Research Council, Hydrogen Optimized CC Energy, who help us in the work that CFHCA does. So who are we? First of all, who am I? I had a great introduction from Trav, and I appreciate that. But I just want to say that I've been fortunate enough over the past many years to work with hydrogen in many different aspects. And so not only within major industrial gases company, working with customers that are using hydrogen, competing to supply them with hydrogen, also running logistics to supply that hydrogen from plants right across North America. So it gave me a real understanding of the various modes and operations and ways that you can supply hydrogen to customers, whether they're refineries or whether they're smaller users. And then, working in the hydrogen fuel cell industry and sector, seeing how it uses in clean energy, how it's used in clean energy applications, working on designing equipment for using hydrogen, handling it safely, and so on. And then as leading a company that was using hydrogen to do transformation, again, understanding the safety, how do you handle equipment for it. So it's given me sort of a bit of a perspective on what it takes and what are some of the demands for hydrogen in various applications. As far as the CFHCA, it is a Canadian association that represents the sector in Canada, over 200 members now, and do the important work that associations do, industry associations do in terms of advocacy, government relations, communications, and networking. We are right across Canada, and we have affiliates in the regions because we're finding more and more that you really need to work at the regional level to get things done, and that's it's very important to have local chapters and groups that can work with the local municipalities and governments to get projects underway. These are some of our members, and they represent a wide range in the hydrogen value sector, everything from energy companies to component suppliers, tech companies, universities, and so on and so forth. So many of them will be very familiar to you, and many of them are Canadian-based and world-leading in the products that they produce, whether that's fuel cell products or electrolyzer products or other services. I will say one thing, is that in the CFHCA, we are really agnostic. We're in favor of clean or low carbon intensity hydrogen, but we really are not too worried about pathways. We think that as long as a pathway can be certified as low carbon intensity, then it should be encouraged to compete and to participate in the market, because hydrogen cost, availability, and ability to scale are really critical, and we need hydrogen from many different pathways. And in our association, we're pleased to have companies working in pretty well every color of the rainbow in hydrogen: blue, green, turquoise, pink, you name it. So that's one of the things that we think is really important if we're going to be successful in seeing hydrogen broadly adopted. All right, a little bit about hydrogen in Canada and where we see it happening here. And this won't be too new to most people, but it is known that hydrogen is going to be a key part of getting to net zero. So aviation, obviously very critical, but it's really also important in many other segments. Many types of transportation, particularly heavier duty transportation, heavy industries like cement, steel, chemical production, refining even. In building heat as a way of decarbonizing the heating of buildings and of industries in situations where electrification is perhaps going to be expensive or not suitable for the needs, and for long-term energy storage and supply. So really, I think it's often called the Swiss Army knife of decarbonization technologies. We're seeing that and really started in around 2018, but really an ever ramping interest in hydrogen, really driven by policy, particularly the need for net zero, by the improvements in the products and technologies that are out there, the performance of the fuel cell vehicles, performance of hydrogen internal combustion technology, and in production and distribution technologies. Where Canada stands is as a number one leading energy exporter today, all types of energy, oil and gas, electricity, and so on. We're a top 10 hydrogen producer, over 3 million tons a year. We have 3 major liquid hydrogen plants with more planned. Many years experience in fuel cell products and technology, over 40 years, and over 100 years of expertise in electrolyzer technology. And we currently export technology, including fuel cells, around the world. In many ways, the Vancouver area is considered the cradle of the modern fuel cell, with PEM fuel cell, with Ballard Power based there, and many more companies that have grown up in that area. And Southern Ontario, we've got a very strong electrolyzer expertise, again, major companies that are flying around the world. And we are currently producing clean hydrogen. In addition to industrial hydrogen, there is a growing amount of clean hydrogen being produced, particularly in Quebec from the renewable power, the hydropower there. And in Alberta, combining SMR with carbon capture and sequestration. And those are both growing rapidly, and there are more projects planned across the country. Way we make it, say steam reforming with carbon management, green hydrogen. There's also quite a bit of work being done on the so-called turquoise hydrogen here, where you do pyrolysis of natural gas and also biomass, production of hydrogen from biomass. There's a number of companies working on technologies in that area. It's moved via, we have an existing network of liquid hydrogen distribution, which is really integrated with the entire North American liquid hydrogen logistics systems. And there are some pipeline complexes as well, particularly in Alberta and Southern Ontario. There is a growing interest in exploiting Canada's low-cost clean power for export, and some significant projects underway in our East Coast in Newfoundland. Some multi-billion-dollar projects that are moving forward to produce green hydrogen for export to Europe, and also looking on the West Coast. So quite a bit of work happening in this area. And we got good support. There's in Canada, has been legislation to support moving to lower emissions, including low carbon or ZEV vehicle mandates. We've got good support from the governments at the federal and provincial level on developing roadmaps and plans for this, strategies for hydrogen. And more recently, somewhat in response to the production tax credits in the US, we've got clean tax credits for hydrogen production and technologies, which are looking to support the investments in infrastructure. And we have a growth fund, which similar in some ways to the money the DOE is making available for hubs. It's not specifically to hubs, but it can be used for that sort of area. And there are some big projects moving forward to support hubs in Canada. So quite a bit of work in Canada. That's a bit of the advertisement. Let's talk a little bit about hydrogen for aviation. First of all, I am by no means an aviation expert, and I just look at this from the outside, from the perspective of having seen hydrogen and fuel cells adopted in some other sectors. And I think that it is a pretty safe assumption that over the next 10 to 20 years, there will be a hydrogen-fueled aircraft will be developed, and that they'll offer competitive cost and performance. And I think that's the key thing is going to really be around hydrogen costs and availability. In the short term, another assumption that I would make is that airports will largely be supplied with liquid hydrogen, at least in the earlier years, and then over time would transition or be supplemented by on-site or pipeline. And I'll talk a little bit more about why that's, I think, a reasonable assumption, and why it means that the commercialization of hydrogen and other transportation applications is really quite essential, and especially I'll say in heavy-duty trucking, because in that area, and just cutting the chase, the buildup of scale and a reduction in cost that has to happen for the safe and efficient commercialization of hydrogen in trucking will translate to aviation. And I think it really needs to lead aviation in terms of its rollout. And so that's a critical thing. Where we're seeing hydrogen deployments happen in Canada, and I think this is pretty common around the world, is it tends to cluster around what have been called hubs. Oftentimes these hubs are industrial processing centers where you get big users, chemical, petrochemical users, fertilizer producers, that are already using large amounts of hydrogen and are starting to clean up and decarbonize that hydrogen supply. You're also seeing investments around the world in biochemical and biofuel production, and those tend to be large demands, and so they tend to also produce a center for hydrogen production and distribution. And then what we're seeing is that by and large, the transportation applications are also coming in clusters. They need to. They sort of we've done over the past decades. We've done sort of standalone demonstrations that really aren't economical, and now it's recognized that we really need to get some scale together and some significant rollouts of transportation applications to really get the economics to where they need to be. In the early days, hubs can certainly provide the best economics. You know, what you're doing there is you're looking to say, and it makes perfect sense that, you know, the cost to produce hydrogen goes down with scale. And so it makes sense to cluster together applications. But I think what is also becoming apparent is that it's very difficult to supply hydrogen fueling stations from a hub. There are some special cases where that'll happen, but you need pipeline costs, and then even when you get that done, you still need at the fueling station compression, storage, etc. And it's a kind of unusual situation where you'll find there are there and they need to be exploited, but it's not that common that you'll find a fueling station that can be attached onto a large-scale hydrogen production facility. They just aren't in the right places. Put the pipelines in to supply them is a major undertaking. Something can be taken, but it's going to take some time. What seems to be actually happening is that there's instead either a liquefier or a high-pressure gaseous distribution system attached to a hub or a large-scale production, and then it is moved by distribution systems to the hydrogen fueling stations. And that's what's happening in California with one of the largest fueling station networks in the world. That's what's happening in other parts around North America in particular, where we do have a good liquid hydrogen distribution infrastructure. I think that's a key point, is that you know, I'm very much in favor of hubs and hub development in terms of as a large scale supply hooked up to directly to a station, but recognize that really we need to think of hubs larger as they're being thought of in the US with the hub projects as an ecosystem where you have production, you also have those distribution, and you also have the stations and the applications tied together. It really has to all come together. The other thing we're seeing is that in the transportation applications in particular, that you have to think beyond a hub and think more about a corridor. And again, I think this is, depending on your definition of a hub, this is, you know, may be obvious to a lot of people already, but if you think of this a hub as being one small geographic area, you really need to think of a corridor to connect those hubs and to provide the nodes, if you want, between those for fueling, so that the trucking companies can look at this and see that there's, you know, an ability to support their trucking through the areas that they operate. And also these overlay with the rail transportation and also can integrate the bus transportation in the same area. So these types of corridors look like they're going to be necessary to really kickstart and get the transportation applications moving. I've shown one here, which is planned, but you know, certainly in the very early stages of a corridor running from Windsor to Quebec in Canada. That's the busiest trucking and highway corridor in Canada. Probably 2/3 of Canadians live along that corridor, and it is a you know, very large scale movement of vehicles along that route. It also connects, of course, down into the United States through Windsor into Detroit, and from Montreal down into New York State, and across from into St. Catherine. So, be an important link in similar corridors that, of course, you're going to have 10 times as many corridors in the United States to support trucking down there. But this what it seems to be is that it's not good enough just to look at even a hub for the transportation applications. You really ought to start looking at putting corridors in place, which increases the scale, increases the risk, increases the investment that's needed, and makes it really quite challenging. But that's what's needed to move forward. And I'm delighted that the hubs awards have happened now. I should mention that I also sit on the board of HTEC, which is very active in the development of these types of corridors, and they're part of the Northwest Hub Award project. So looking forward to seeing that Pacific Northwest project move forward, and to having the company I sit on the board of participating in that. So again, to get these mobility applications going, you really need to get a flywheel going. First step in it is that stations need to go onto the ground. I mean, you need those stations and those corridors to start coming on before you can really promote and supply hydrogen vehicles. Particularly in the heavy duty trucking area. And then as that ramps up, you need to start increasing the supply of low cost, low carbon hydrogen, which requires large scale and can potentially also be done with distributed on-site supply. You need to invest in that distribution infrastructure, the pipelines and the liquefiers, and then take those learnings, cost reductions, and efficiency improvements to build and operate more hydrogen networks. For aviation, I think that what has to happen is it needs to be integrated in. As this flywheel starts moving with heavy duty trucking, then you'll be able to start integrating in other transportation applications, such as aviation, taking advantage of the cost reductions that are going forward. But the reality is that each step along this way is high risk, high cost, and has challenging returns. And there is really a strong need for government support and very bold corporate moves. And there are very positive signals that this support is coming in place. As I say, particularly the DOE subsidies and the consortium reforms in that. And we have similar projects happening in Canada. When you get down to the refueling at an individual site, whether that be an airport fueling system or a truck fueling system, it's part of an overall, as I say, hub and node. But individually at that site, you're going to have a choice of compressed gaseous supply from high pressure tube trailers, which is okay for small scale, but really, if you look at the demand that's going to happen at a heavy duty station, at a bus fleet, and certainly when you get to an airport, it's going to be very challenging to try and move on sufficient hydrogen for those scales. Liquid actually allows you to fill in that gap quite nicely. Liquid systems are relatively low cost to install. You have a liquid storage tank. You run liquid tractor trailers to the site. They pump the liquid into those tanks. You, instead of needing a large and high maintenance and power demanding gaseous compressor at the site, you can do liquid hydrogen pumping and vaporization, which is it's the way we used to fill cylinders 30 years ago. It's a much easier way to compress and hydrogen to high gaseous pressures, to the 700 bars that are needed for onboard storage. Therefore you need a much smaller storage system. And the footprint, by the way, of these gaseous storage tanks can be very, very large. So this allows you to have a much smaller facility, one that can ramp up and ramp down very, very easily and quickly, and in general just lends itself to a scaling demand in for mobility applications. Over time, you can start looking at putting on site such as SMR or electrolyzer systems, but they are, and the experience of having built and supplied equipment for these things and operated them, it takes quite a bit of cost and capital and space and maintenance and manpower to run an on-site facility. So it's really only once you've got a large, stable demand that these start to become cost-effective and so on. And even then, in most cases, you'll probably maintain a merchant liquid system as a backup for that and for peaking. So it becomes a way to cost reduce liquid supply by putting your on-site in place. Don't forget, for a mobility application, you either need very possibly onboard liquid, which means you really do need to have liquid delivered to the site, or you're going to have very, very high pressure gaseous supply. It also needs to be, if it's going to be a fuel cell application, very high purity. So even if you have an on-site gaseous plant producing at low pressure, you're still going to have a large-scale purification system, compression system, and storage system so it can run stably. What that means is it's going to take time before you can get to that type of a supply system. In the meantime, you're going to be probably looking at a merchant system in the short term. So this shows you what one looks like. This ran very successfully, supplying 20 buses, a ton a day in Whistler more than a decade ago. They still work well. You have a liquid storage tank, vertical system, a liquid compressor running through those vaporizers and into a relatively modest storage system. So quite scalable, reliable, safe, compact, can produce gaseous or liquid supply, requires minimal power, got high reliability, and so on, and can be cost competitive with diesel, but it needs to have something like a clean fuel standard and a carbon tax or a low carbon fuel standard in place for that to happen. When you look at the economics today, and these, please don't quote me on this, but this comes from having looked at building projects and seeing what's going on and so on. And this is approximate values and for illustration, and I'm sure people can challenge it. But what you're looking at is if you go to buy hydrogen today from a very large producer, like a byproduct hydrogen from a chlor-alkali plant, or a very large electrolytic producer, or so on, you'll get down to sort of that $5 a kilogram for an offtake. If you're, I know there's certainly a goal from the UE to get that down to $1 a kilogram, but that is a ways off. Today, you're looking at quite a bit more for your basic gaseous offtake. If you can sort of approach a company and say, hey, I'm willing to buy hydrogen from you, that's what it's going to cost. That's what they're going to charge you for that. Hopefully, often more. You then need to put in a liquefier. Liquefiers, typical capacity today is 20 tons a day. You're going to have $300 a kilogram of OPEX to run that if you've got a good power rate, and you're going to have about a $300 million CapEx for that. So that's what Air Liquide is building in California right now, and that's what's being looked at and there's projects underway in a number of other places. That's the type of number you're looking at. So significant amount of money for 20 tons a day. That'll support a network of fueling stations. A typical large fueling station may do 5 tons a day if you get it fully loaded. It's going to add another $1 a kilogram for your distribution and your OPEX on that. It's going to be about a 10 million CapEx. And so in any sort of a quarter, you're going to say, let's say a minimum of 4 fully loaded. In that reality, you probably need more than that, and it'll take them a while to get fully loaded. Another reason why networking together and building and cooperating between trucking and other applications is important. That would support about 500 trucks. Those are currently about $250,000 or $750,000 each. Price though is coming down, but again, support needed. And what and this is very debatable, but the price that is needed by those trucking companies to be cost competitive, somewhere less than $10 a kilogram for sure. And so what you've got is a bit of a squeeze here. You know, you've got your OPEX pretty close to what your selling price needs to be. And if, you know, just do some economics on this, just the liquefier and refueling station, if you're looking at sort of 350 million of capex there, you know, you're going to need to be, and you're fully loaded, you're going to need another $10 a kilogram to get a reasonable payback on that. So all of a sudden you got a disconnect here between the liquid price and the selling price that's needed to support the sector. That's where the challenge is right now. That's why the support coming from the governments to move these projects forward is really important. Over time, production costs will come down, liquefier scale will increase and costs will come down. And so you can start having these stand on their own. But right now it is a bit of a squeeze, and I can say, you know, personal experience, it's hard, very hard. When you're looking at these, you know, sort of $500 million of capex required to get a project underway and get a corridor, reasonable sized corridor moving. It's a difficult challenge right now to pull that economics together. So that's just the problem, but that's what we all had to face. So what recommendations? Number one is cooperation. I would encourage that, you know, a lot of cooperation between the aviation sector and the other mobility sectors that are looking at decarbonizing, trucking, light duty, rail, etc., the off-road and so on. I think there's no one silver bullet on the policy end of it. You need levels of support in multiple levels, ZEV mandates, production tax credits, support for vehicle purchases, and then a low carbon fuel standard or something equivalent to provide some equalization on the cost versus diesel. In the demonstration end, my suggestion is, you know, urgent need for demonstration, obviously, of aviation needs, lightweight fuel cells, hydrogen turbine storage, integration of fueling procedures, so on. But I would say there's also a need to build demand by really starting to get those ground applications underway. You know, that's obviously not going to be a critical need for the aviation sector in terms of, you know, their overall GHG footprint, but by working on that, we'll help build the infrastructure for the aviation needs. And then for the actual fueling of that, I would say you'll probably have to rely on merchant for the short term. It will be more expensive, and that's why government support's needed. But over time, with the build out of the infrastructure, that will come down and become competitive with the aviation fuels. So that's sort of a very high level thought on what's needed. I say I'm delighted to hear the moving forward of the hubs, which will provide much of this support. I anticipate for those areas in the US. We have, again, similar projects underway in Canada. And so I'm extremely, you know, excited about where things are going. I see it as an enormous business opportunity. When you look at the numbers, a typical city of 1 million people will need $1 billion a year of hydrogen to support its trucking operations, and more for its aviation and rail and other things. So that's a heck of a business opportunity. And that $1 billion, by the way, will be replacing a higher amount of diesel and gasoline in that market. So we're not looking at, you know, an increase in costs. There shouldn't be over time an increase in costs for those transportation companies. It actually should be a reduction in costs for them over time as that infrastructure comes in. But still, a huge capital investment needed, a big economic opportunity, but with its challenges. And that's it for what I wanted to talk to you about. But I do look forward to any questions that might come up. And also, I put up here the name and email of my successor, Yvette Vera-Perez, who is doing a fabulous job leading the Canadian hydrogen fuel cell sector and helping to ensure that the industry is well represented in Canada and around the world. And I encourage you to reach out to her as well if you have any questions or interested in the Canadian market. Thank you very much.
Thanks so much, Mark. Fantastic job. Really cool to kind of hear about some of the similarities between the US and Canada. We have a few questions in the chat, but first I was wondering if you could just kind of talk to something that it's a technical question that I've never understood, but you mentioned if you're going to be using the hydrogen in a fuel cell, that hydrogen needs to be really pure. If you were just like making the hydrogen with an electrolyzer, wouldn't it be pure? What would cause the hydrogen not to be pure? Is it if you're making it some other way?
So yes, if you make it with an SMR, you need a purification
Steam
step.
methane reforming.
Yeah, steam methane reforming or autothermal reforming. You definitely need to have a purification step. That's well known. And there are, I mean, I used to build them. There are technologies out there that can hit the 5 nines purity that are going to be needed. If you are, so that's known. If you're an electrolyzer, yeah, most electrolyzers, there may need to be some scrubbing of water and oxygen in some cases, but in general, they're also going to produce the purity that is needed for it. It's not going to be the pressure you need. So you're going to have a step-up compression system, and obviously it's going to be gaseous. So if you need liquid, particularly you're starting to think about aviation where onboard liquid looks like it's going to be quite viable, then there's a whole nother big step to take that gaseous product and liquefy it. But the nice thing is that if you're buying liquid hydrogen as your base supply, you've got that pure. It is already been purified to very high levels and is quite suitable for use in a fuel cell.
Okay, thanks. That I've never known the answer to that, and now I do. So interestingly enough, we had a gentleman at Flying High named Mark Haberbush, and he's the CEO of a company called NeoX, where they're building hydrogen powered drones, and he was struggling to get liquid hydrogen, so he actually built and he's selling them. So if anybody's interested, not an electrolyzer, but well, he will eventually, but it's a mobile liquefaction system. So you can get gaseous hydrogen and then put it through his system and turn it into liquid to put on board an aircraft. So I thought that was interesting. It was easier for him to sort of build his own than to kind of try to find, what he needed.
I think that's exciting to hear. There's some very interesting technologies that are coming out in many ways in distribution. I mean, there's the liquid organic hydrogen carriers. There's solid state systems. There's slush systems. There's various on-site technologies from all sorts of different applications. I'm sort of looking at where the state is today of proven robust industrial technologies, but yes, there are lots of opportunities to lower the costs of production, liquefaction, distribution, and so on. I would, I encourage people not to get starry-eyed about some of these technologies because it is having worked in this myself. It takes a long time. Usually, what you're doing is, you're incrementally lowering the cost of something. So again, it might mean that the break-even point between on-site liquid and having an on-site plant shifts to a bit smaller volume. You can do it a little earlier, but I don't think it's going to change that fundamental paradigm that, as you're getting your demand built, particularly in these mobility applications where space is going to be a problem, where you don't want to have a lot of work. I think it's really going to make sense to start with that distributed liquid or potentially high pressure gases in some cases supply, and then look to transition over time to the on-site applications. Now, that said, we are in a real hydrogen supply shortage right now. It's hurting the entire sector. It's really ugly. It's interesting. It's changed from a few years back. But right now, if you want to try and buy liquid hydrogen, the industrial gas companies are in control, and they are, continuing to supply their industrial customers. They have to do that reliably, and they therefore are charging quite a bit for any new customers coming along for liquid hydrogen. There is new capacity coming in. There's a lot of new capacity announced, but it takes time. Those are, multi-year projects to get underway. And right now we are in a very tight supply squeeze. I would say, that's frustrating. I understand, and it I hear a lot of pricing in California right now is at fueling stations has gone through the roof. The best solution to high prices is actually high prices, and so I do think that what that is doing is encouraging the building of infrastructure and demand. The numbers I showed are sort of outside of the short-term demand. They're more the basic capital costs and operating costs and the returns you need on those. But I do recognize that right now we're in a very tight squeeze. It's affecting the company I sit in, HTEC's operations, affecting others. I do think that will improve over time, but only with this sort of flywheel building, because to make those major capital investments, you need to have offtakes, you need to have demand. So, and that only comes if, there's an airport saying, yes, we will convert our buses and commit to purchasing the product from it. If we can get that going, then you can get those economics and those investments happening. But it's sort of the early stages right now. We've got to get that flywheel moving, and then I think it'll start going very, very quickly.
You're totally inside my brain. I don't know if I've ever told you this before, but prior to starting High Sky, I was part of a hydrogen aircraft company where we successfully flew with hydrogen, which, a lot of people think, oh, it's dangerous and this sort of thing. By the way, for those of you that weren't in person last week, we had Lieutenant Colonel Dunn from the Air Force do a presentation on, this is totally a tangent, but we had to do a presentation on working with the Air Force. But anyway, in his presentation, he showed some slides where they had a tank of hydrogen that they literally just shot at, trying to, the Air Force, opposite of, us in industry, we don't want it to explode, but they were trying to make it explode to use, for other use cases, and they couldn't. So that made me really happy, just to hear that they were really, really trying to make this thing explode and they couldn't. But anyway, what I was going to say was, back to my story, in this startup, we successfully flew with hydrogen, and our biggest challenge was actually getting hydrogen. We had to drive hours. It was very expensive. It was just totally inefficient process. And that problem, hey, we see you now. And that problem is actually what the High Sky Society was born out of, because we said, this is the most abundant molecule in the universe, and we can't get it, or it's very inconvenient for us to get. I wonder who else is having this problem. And everybody that we talked to said, yep, that's exactly what we're going through as well. So we said, all right, we're going to form High Sky Society. And then to your next point, when you start talking about offtake and the demand problem, we're very much involved in, I don't know if you saw the Department of Energy put $500 to $1 billion out for to solve the demand side problem. And we did an invite-only meeting last week with some folks to discuss our approach and solution for at least aviation's role in the demand side problem. And I said exactly what you said about the airports. And not only do we need the airports saying, yes, we'll convert XYZ, but also the airlines saying that we're, if we can access, because the airlines really would be the big, purchaser of the fuel, the hydrogen. And so we really need to have them involved in this conversation that's saying, if we can get it for X price, then we'll commit to doing it. So those are all things that we're working on. I always love when I feel validated by an expert such as yourself. So, yeah.
Well, I think that's incredibly important, and I really do. I do appreciate that a lot, because looking at it from a perspective of a company looking to get projects underway, and secure financing from not only government but also from the private sector. The demand side and offtakes are absolutely essential. Yep. And so what we can do to try and collaborate between the various different sectors to get that demand together will really help to stimulate the build out of infrastructure, and that will help to drive costs down and improve reliability and all those good things that we want to see happen. So I think there's a lot of work to be done in that area, but I am very encouraged by some of the work that we are seeing from associations such as yours and so on.
Yeah, and you said another important thing at the meeting. One of the attendees said, well, 500 to $1 billion is a drop in the bucket. That's not really going to bring down cost. And what I said, and I'd love to hear what your take is on that. I said, well, yeah, it's the intent isn't to solve the entire problem. The intent is to start to drive down costs and sort of de-risk it from the private side, so that for the private sector will step up and really put the big bucks that are needed in. So what's your take on that?
Yeah, absolutely. I mean, we're working with big institutional investors now, and they're all very keen to be part of these projects, but they need to see, the economics, and they also are very worried about the risk on policy, risk on, the technology, as well as on project execution risks and so on. So, from the private sector will participate, but there is a real need for de-risking capital right now. If you can have some demand certainty, then you don't actually need the money so much. You just need to know that if it, for whatever reason, doesn't materialize, that you've got a backstop for that, then that can help you moving forward. That's what the low carbon fuel standard provides for fueling stations in California, or it did. Now we've got a problem that those credits have plummeted in value, so it's again challenged. But that type of a mechanism is really important to move that forward. Again, I say I'm optimistic, but I do recognize the challenges that are there right now. We absolutely have to get this to be a money-making business for the private sector. Right now, there's a gap. It will improve, but you need that government money to close that gap right now.
Yeah, and I'm curious, and I promise I'll get to the questions in the chat. But I'm excited to have this was so timely. I think it was total accident. It was just, it sort of lined up this way. But perfect timing on this talk. What do you think? I'm really putting you on the spot here, but what do you see as like a demand side solution? Say you were, I'm asking this for selfish reasons. Say you were going after that funding, what do you see sort of like the ideal solution if there were no limitations?
I mean, in terms of the policy,
if you were going after the funding, the 500 to $1 billion to solve the demand side problem, what does that look like? What do you think industry needs and DOE wants to see?
All right, I think it's a bit like what happened in the material handling area. You need to come up with projects that have the full value cycle together. So, the companies started coming forward, and people may be familiar, but there's 40,000 fuel cell forklifts out there, and it's the biggest demand for liquid hydrogen in North America now. And that came about not because of anything other than it made economic sense to do that versus putting battery systems into fuel cell forklifts. What had to happen for that to go forward was companies coming up with complete solutions for the customers. So they had to come up with the forklifts, they had to come up with the fueling stations, they had to come up with the hydrogen supply, and offer that as a package. And when you did that, it started moving forward. We need to do the same thing in the other applications, which means some corporation needs to take that risk on all those aspects: production, distribution, fueling stations, and vehicles, and offer that now as a service, I think, to the trucking companies. I talk about trucking companies a lot now because that is the big demand that's going to really drive things. If you look at the amount of energy in the trucking sector and their needs, hydrogen is a good fit, and it's going to be a huge demand for it. So I think that whole complete solution needs to come together. Now, you see companies trying to work on it. Nikola and others are all trying to work on it. My company that I said on the board, we're trying to work on that same type of approach, but it makes the scale of the project bigger. So what you need from government is you need all aspects. You need the trucking companies see clearly that they are going to have to start phasing out internal combustion and moving towards zero emission vehicles. You need, so that's zero emission vehicle mandates. You need to have, you know, some support for that massive capital that's going out there. So production tax credits, direct grants, et cetera, that you can use. In Canada, we have low carbon fuel credits in BC that you get granted in advance and you can use to help support your capital. That's been a great approach to getting things moving forward here. And then, so that allows you to justify the cost. And then to narrow that gap, which you also need, you need between the diesel and hydrogen, you need an ongoing credit like a low carbon fuel standard to help narrow that gap. And then finally, you need grants to the purchase of those vehicles to narrow the cost differential between them. So it's not, again, it's not a silver bullet. You need to have that full raft of policy support together to make that work. I would say if you look around North America right now, that ecosystem is in place in BC, and it's going to move forward here. It's in place in California. It's coming in place in the Pacific Northwest. And we will see where else it starts to get all those pieces together. Because I really do think you need them all for a company to be able to say confidently, okay, we'll slap down that. Yeah.
Do you see Plug Power as being one of those companies that's got
Absolutely.
that ecosystem?
Absolutely. I mean, Plug Power did that in the fuel cell forklift business already, and I think they're very keen to do that in trucking and other areas.
Well, and a lot of people don't know they have an aviation division as well.
Right.
They've presented here a couple times. They're developing an aircraft. So yeah, I've kind of been blown away with some of the things that, like, you guys are doing everything.
Yeah, they are, absolutely.
I got to, I guess.
Yeah, no, they are, and they got some very ambitious projects underway, and have executed and have got things moving forward. And I will say there are others as well that are which is good. We need competition in that area to help get the cost down. But right now we need collaboration, frankly, more than competition. We need to, support, and that's what we're seeing with. If you look at, let's say, that's the one I'm familiar with, Pacific Northwest, the number of partners that are coming together, collaborating at this point, and I'm hopeful that will lead to some significant projects moving forward.
It's interesting that you said Pacific Northwest. I've been engaged with them on a few things, and I am blown away by how much they have going on and who all's involved. Yeah. They had to have been working on that for years. Before I even heard about them.
Credit to the, and my mind's gone blank, I can't think of her name right now, but credit to the association up there, Pacific Northwest Clean Renewable Fuels Association. They've done an amazing job of lining up the various players and engaging them. And I think that really led to this, to that good quality proposal that came out of there. So yeah, I can't remember the name, but really good group that are doing work there.
Yeah. Well, okay, so let's see. Ovi says, Ovi, do you want to come on? I could ask this one. Well, I could ask the first part, but why don't you come on, Ovi, and ask your question?
Let me see if I can find my question.
You said, could you provide us with a list of electrolyzer companies in Canada? And then what is the backlog for delivery for these units?
Great question. Supply chain, we're buying them too, and man, it's taking a long time to get these products. So a couple of companies in Canada, Cummins, obviously a big American company, but they run their electrolyzer division out of Canada. And they have a whole division now devoted to electrolyzers. They've supplied to their current largest one is operating in the Quebec area, but they supply around the world. So they're an obvious one. Hydrogen Optimized is a new company built from the Stewart family, who've been literally involved in it for over 100 years. And they've got a new technology. They're building a production facility in Owen Sound, Ontario. Building on the automotive sector that's up there, and they got some very interesting technologies for large scale electrolyzers. And there are a number of others that are in the that have technology-related electrolyzers. Companies like Ionomer that are developing membrane technologies around and advancing that for electrolyzer and fuel cell production. And others too. Next Hydrogen is another company that's supplying electrolyzer systems.
What was the one you said right before Next Hydrogen? The membrane folks.
Ionomer, IONMER, I think.
That's a cool name.
Yeah. Yeah,
I
they're
will
great.
look that up.
They've done some really interesting things and got partnerships with a lot of different companies.
Cool. I'll definitely have to look. And then Next Hydrogen, you said was another one.
Yep. Yeah.
Yep, familiar with them. There's like a weird kind of staticky sound. I don't know if it's on your mic.
Possibly could be. Judging by the fact the problems I have with my camera, it's
I know. I'm like hesitant to tell you to change anything. Okay, let's see. Next question is from Dan Newman. This is a good one. And I don't know. I mean, you know, guys, keep in mind, Mark is from the Canadian hydrogen fuel cell group. I didn't say the whole nonprofit, but so I don't know how much you'll know about this, but what are the biggest lessons learned? Oh, sorry, this is from the Canadian hubs that can be, I looked at it and thought I saw California. Okay, what is the biggest, this is why I tell people to unmute. Dan, do you want to come on and ask your question? Because I butcher them.
But
Dan,
I think just responding to that, and I would not pretend to be, you know, that Canada is hugely further ahead than the US, but I think the most advanced one we got is Edmonton, where there is 500,000 tons of clean hydrogen being produced. There's a pipeline complex they're building out. It is that you need to get the local municipalities and provincial governments or state governments involved in, and it really becomes promotion. What hubs are trying to do in the Canadian context is attract investment. And they've been very successful in Edmonton. They've got some multi-billion-dollar projects moving forward because of the ability to produce clean hydrogen there, which was enabled through some government support on CO2 pipelines and sequestration capabilities. So now you've got, you know, companies like ExxonMobil and Shell making multi-billion-dollar investments in clean fuel and clean chemical production facilities because they know they can get that low carbon intensity hydrogen there. So I think it's really in the interest of areas to, you know, start identifying what are the advantages that they can bring to the table, making sure they're putting the support for you know, codes or regulation approvals and so on, which can be challenging, getting that in place, and then working to actively promote it. And what it, you know, leads to is investment and companies coming in. And we really are seeing that, I think, most particularly in the Edmonton, Alberta area, where we've got a whole array of industrial processing applications happening. Now it's moving into buses, rail, there's locomotive projects, trucking projects, et cetera, that are happening. The Edmonton airport has been a leader, and they have a full intention of putting in a whole fleet of vehicles at the airport. And again, in preparation for hydrogen aviation in the future, but they are very engaged today in supporting that hub with demand, and there's a whole plan to run really a pipeline across the city for them.
I would love an introduction to Edmonton Airport if you have one. They would be, I think, a real cool group to get on one of these webinars.
Absolutely.
I think the closest thing we've had is SoCal Gas, and they're doing some research at the airport, but we haven't had an actual airport. So yeah, that'd be huge.
No, the airport's actually a member of the association now, and are
cool.
actively engaged in the hub. Yeah, they're a great group. So yes, delighted to do that.
Okay, thank you. Let's see. So next we have Samantha. It's a long question. I'll do my best to read it. He said he might not be here to listen to his answer, so I'll read it. Having worked with TCG, I know they have done a super job with the H2 transportation regulations. I have no idea what TCG is. I hope you do.
Transport Canada? Maybe, I don't know. Okay.
Maybe. Can Mark comment, maybe the rest of the question will give us some insight. Can Mark comment on the status of local jurisdiction and authorities having jurisdiction in their adoption of H2 hubs and even H2 storage systems? Is it onerous to get approval of hubs, or is there a federal Canadian policy that is being put in place? I'm very familiar with the US, but wanted to get Mark's take on the Canadian regulations and where they're headed.
Yeah, that sounds like it's Transport Canada who regulate the vehicles and homologation of vehicles and that sort of thing. We also have our local, you get local approvals from the municipalities and from the fire marshals and so on. We've been involved in standard development for years. We have got there are, and they're not Canadian. They are actually North American standards in place now for most of the aspects, siting of hydrogen systems, the equipment, and so on and so forth. There are some gaps that need to be filled. Dispensing systems are still a bit of an open issue right now, but there is quite a bit of standard work that's been done. That said, it is a pain in the neck to get standards and local approval because it's still new. And when you go and talk to, we have a big project moving forward in a town in BC. We had to go and work very closely with the council. We had to go through hearings. We had to do a lot of work to get approvals and permitting approvals. So I don't think we have any magic bullet here. And it's one of the messages we send out to governments at all levels is, what can we do to help streamline permitting, because it is really slowing down projects. I think certainly some of the things that help are we're seeing the colleges now involved in getting certification standards in place for technicians. That raises awareness. There's a real role for associations and so on to communicate broadly so people are aware this is going to come down, and maybe start helping to get that ground smooth, level the ground before a company has to come in and do that work. But it is a big effort that companies have to take on. It takes time, it slows down projects, and it is difficult. I'm optimistic that over time it will get better. But this is again where I think hubs are really important, because by having a group working in hubs, you can bring in your local authorities and regulated authorities and get them familiar with what's happening and why. And then when time comes for them to look at a fueling station or whatever it happens to be, at least you're not starting from ground zero. They are somewhat familiar, and you don't immediately start saying, "Oh, Hindenburg," and panicking. So.
Yeah, I just say H word now. I always say the H word, and I'm not talking about hydrogen. I'm trying not even to say it anymore. That's great. Rick Gassaway asks, were the prices on your slides shown in US money or Canadian money?
I'd say those are probably, I was thinking more in Canadian dollars. So add at least 30% to that or subtract 30% in US dollars. But that's what I was thinking of in those terms. Again, representative only, you're going to see differences in regionally. You're going to see, I think a lot of people argue about some of those numbers and so on. But that sort of gives a represent. And the main point I wanted to make is the fact that liquid hydrogen is necessary, but we have a real challenge right now, in that if you look at the cost, it is still higher than what the selling price needs to be. And how much difference, debatable, but it's definitely there's a gap there, and that has to be filled right now with government support. Yeah.
Michael Kramer, do you want to unmute and ask your question?
Sure, I'll give it a shot. Hey, Danielle's rolling her eyes because she knows I'm that guy. The guy.
I'm not rolling my eyes. I'm looking for my mute button so you can have the stage.
Feeling the love, Danielle. Feeling the love.
But he does give our guests a hard time. Go ahead, Kramer.
And the hard time is just strictly from a cost competitive standpoint. Green hydrogen, to be competitive with jet fuel, you got to be able to do it at the wing. For pre-pandemic was $1.90. Today, S&P is calling out as $2.96 a gallon at the wing in the US. By the way, the reason I mentioned Gander, Newfoundland is pumped hydro with wind is about the only way I can think of storing wind to make it cost competitive for an electrolysis machine running full time. But what are your thoughts on it? Are we just kidding ourselves, or you think you can get the cost to be competitive?
I think
That
there's a
guy,
real
right?
challenge there. Honestly, Michael, I think it is a real challenge, and we struggle with this, you know, from a practical project point of view every day. I agree with you. If you're looking at green hydrogen, you really need very large scale, low cost power to be remotely competitive. You know, we do see that in some places you can get there. There's, you know, quite a number of places in states that have got that in the Southwest and so on. So I think you can get with scale, you can get the basic gaseous hydrogen cost down to, you know, not down to $3 delivered, but you can get it down to that price. You can foresee getting it down to that sort of a cost at those big production facilities. But then you got the challenge is that doesn't help you in getting it to an airport. You got to spend a bunch of money to transport it somehow. You know, pipelines are not going to happen for quite a number of years. So you're looking at moving it either as ammonia, which has costs, or you're looking at moving it as liquid, which has costs. So yeah, I think those are real challenges, and it's going to take some. Well, I mean, I'm not sure you'll ever be able to get it down to the point that you're saying it's got to be sort of $3 a kilogram. You deliver it to the
Yeah, $3 is literally the cost today, but historically it's about $2, and that's at the wing.
Yeah. So I mean, I guess I would say probably you're not going to be able to be cheaper than that fuel. Are you going to be able to be cheaper than biofuels delivered to the wing? Probably. You know, so then it is, you just say that's where it becomes government, is that, okay, what are you willing to either tax or subsidize to close that gap? Because yeah, and I think it's very, you're not going to start certainly in the foreseeable next couple decades, being able to supply hydrogen cheaper than you can produce and supply jet fuel, in my view, when you roll the lane. Now, I would challenge whether, and I don't know the numbers for economics, in the case of transportation for light duty, we sell at the pump now hydrogen for $15 a kilogram in Vancouver, Canadian, and that's a bubble. And that means you come in and you feel
about the same in California now too, by the way.
That's more than that in California, but yeah. But so that's what they sell. It should be lower than that. If you look at the prices that are being paid by the forklift makers at their plants that are under long-term contracts, it's cheaper than that. But anyway, so let's say it's in that sort of range. For a light-duty vehicle, it means it costs you $75 to fill up your car, 5 kilograms of hydrogen. That's very cost competitive with gasoline today. You know, you're going to, in Canada, spend more than that filling up your car. You probably pay a little bit less than that in the US, but that's what you're paying in Canada today. So it's quite competitive. Now on trucking, it's a bit more challenging. Don't have the same energy efficiency that you do with a feeding into diesel on a, diesels are pretty darn efficient running on a highway.
Right.
And so you don't have that efficiency you get from regenerative braking, from the gasoline engines to the diesel engine, so on. So you do need a lower number. It's debatable, but we're seeing that in the Canadian context, really to be head-to-head competitive today, you need to be charging your truckers about $10 a kilogram. So the gap there is being closed with the low carbon fuel standard, and so we are pretty comfortable that we can support truckers, and when we go and talk to them about their lifetime cost of ownership and that sort of thing, we're pretty comfortable we can provide them a competitive offering, vehicles and so on, with the supports that are in place in Canada. I can't comment on the US as well. That's all going to come together. When you get to aviation, Again, I don't know the specifics of how things go together, but there is, you know, there's going to be a gap. You say $3 a kilogram. I can't comment, but I think that, you know, you're ultimately going to wind up with a higher cost than that. And the question is, what is your competitive alternative? You got to decarbonize the aviation sector. What is your competitive alternative? And you know, how do we get that gap closed, or, you know, is that something which you just accept?
I if I could just add to that as well, you said something important. It won't be cheaper, likely won't be cheaper than fossil fuels, but it will be cheaper than batteries for aviation, batteries or SAF, biofuels, whatever. It will be cheaper than those things. So when we're looking at decarbonizing, it is still your best option. To be competitive with fossil fuels is the challenge. Okay, I'm going to move on to Peter Connors. Peter, do you want to ask Mark your question?
Yeah, and so thanks very much. I mean, the comment about needing to liquefy the hydrogen, I thought was very interesting. Do you know what the experience is in California? Do they, you know, that's the place where it's farthest along. Do they liquefy the hydrogen before it's sent to the gas stations, or how does that work?
There's been a whole mix of technologies used in California as these stations have moved forward. In general, what they're moving towards is delivered liquid with pumped, with a pumped compression system. So Element 1 and others that are doing that. Where they get their hydrogen, there's a network of liquid hydrogen plants across North America, about probably close to a dozen, 10 of them so across North America right now. Most of them are not in California, and so they've been having to bring that liquid hydrogen and truck that in from other locations. There's the good thing about it is that once you have it liquified, you can move it a relatively long distance at a relatively modest cost.
And let me just say something really quickly. Sorry to interrupt, Mark, but the reason why, correct me if I'm wrong, Mark, but the reason why Mark is saying most of them aren't in California with respect to the United States is because the pumps in California for the cars, those are gaseous, correct? Those.
Sorry, yes.
Yeah.
Sorry, I get lost in tech. I forgot to get on it.
Yeah.
What you need on a car today is 700 bar gaseous hydrogen. So very high pressure gaseous hydrogen is what is actually on the car. So the question is, how do you get it to the station? You can either make it on site and compress it up, and there are electrolyzer plants running at some of the stations in California. But that's, you know, challenging. And as I say, it's something you will look to as the demand grows. Same with bus stations, by the way. Most bus stations have got liquid, but they're also now moving because they got the scale. They're starting to move to having on-site plants and liquid together to keep their costs at the minimum they can do with that. Excuse me. So if you're moving liquid in, it's just a way of transporting it. So you move it in as liquid, you store it as liquid, and then you take that liquid, you compress it up to 10,000 PSI, and then you vaporize it, and then you put it on the car. And so it is gaseous by the time it gets on the car. There is also a movement to having onboard liquid storage on the vehicles. So you don't put a 700 bar, you transfer liquid into that, not for cars, but more for the heavy trucks and trains, that you'd actually have a liquid tank. It still gets used as a gas in the fuel cell, so you still vaporize it coming out of that tank to use it as the gas in the fuel cell, but it would be, or the internal combustion engine, but it's stored as a liquid.
Wow. Okay, so I had two more comments. Well, one is that Mike mentioned that the price at the pump is $15 a kilogram, you know, which is high, and hopefully will come down. But just keep in mind when we're talking about pricing that there is a $3 a kilogram tax credit for green hydrogen, and that could really make a difference. Mm-hmm. And then you also pointed out that the low carbon fuel standard might be available. Now that's, you know, I don't know what in California it's around $150 to $200 a ton. I don't know what that translates into, you know, on a kilogram per kilogram basis, but you know, that's there, but it's money on the table, right? So, but I would say that the bigger dollar, and I do think that, Danielle, we've always focused on the tax credit, but I think, it's on the table for the grabbing is the low carbon fuel standard in this industry, the aviation industry. It's, you have to show that the energy is being used in transportation. And clearly it is with trucking, and clearly it is with aviation. So, we should maybe spend some more time on that as you and I talk to different groups. Thank you very much, Mark. I really appreciated your comments.
All right, so I think we've got time for one more. Try to find a short one. Let me correct myself. Mike pointed out the Air Force was not trying to blow up the tank. Thank you for correcting me. I confused it with another project where the government was trying to blow one up, but I guess that was different.
Hey, I say, Dan, just to the point, PowerTech in BC, it's a subsidiary of the local power utility. They run a tech center. They have for the past 20 years. They have these big bunkers, and they crush and they shoot bullets at, and they do various nasty things to hydrogen tanks they come in from suppliers around the world. It's great fun. I mean,
I bet. Sounds like it.
But the key thing about them is these things are so solid. You run a car into a wall with a hydrogen tank in it. The hydrogen tank's probably gonna be fine at the end of the day. The car will be dissolved, but the hydrogen tank will be fine. You shoot it with a bullet, you get a jet of hydrogen coming out of it, but it doesn't, blow up like they show them in the movie. So
Yeah.
It's surprising how safe these things are. Anyway.
That's exciting. Okay, that is our time for today. Mark, it has been such a pleasure, so timely. Thank you so very much. I'll really look forward to the Edmonton Airport connection. And if there's anything we can do to help, please reach out. If you have any other questions, feel free to reach out to Mark. I believe he shared his email with you. Thanks again. Thanks, everybody. Have a fantastic week, and we'll see you in a month.
Thanks, everybody. Appreciate the opportunity to speak. Bye for now.